Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to start our foundations of machine learning. Dear friends, we are living in an era where data has become the lifeblood of innovation, driving progress across every domain, from revolutionizing healthcare to transforming entertainment. At the heart of this transformation, exactly, it's machine learning, a technology that empowers computer to understand patterns, predict outcomes, and make decisions with minimal human interventions. Every time you stream a movie, shop online, or ask your phone a question, of course, dear friends, machine learning is quietly working behind the scene, turning vast amount of data into actionable insights. Now let me just see what is the exact foundation one by one here. Dear friends, of course, often whenever we just say machine learning, we often abbreviate as ML. Yeah, it is a rapidly growing field of artificial intelligence that focuses on the development of computer science that can learn from making or make a decision based on a data. Unlike traditional programming where we explicitly define every step, the computer should take, machine learning involves feeding large amount of data into that algorithm that enables the system to learn patterns and make prediction without human intervention. Machine learning is not just about making prediction. It's about discovering insights hidden in this data, enabling machines to perform tasks that were once thought to require human intelligence. Whether it's recognize anything as like photos or translating language mainly in real time or predicting this stock market trends, machine learning is fundamentally transforming industry and the way we interact with the technology. It's the engine behind many modern innovations that we use daily without even realizing it. And why we are specifying machine learning is important. Yes, dear friends, machine learning has become indispensably in today's data-rich world. The sheer amount of data generated every day is enormous. Of course, you can just say text data, image data, audio data, video data, everything, even sensor data coming from social media, smartphones and IoT devices. This dearth of information is far beyond what human can manually process or make sense of. Machine learning steps is here. Yes, exactly. See, as it can analyze vast data set. It can analyze vast data sets and quickly uncover patterns that would otherwise remain hidden, which we just specified. This ability to extract meaning from data is what makes machine learning so crucial. So for an example, in healthcare, machine learning models can predict disease outbreaks. Okay, so improve diagnostic, that is also, and personalized treatment based on the patient data. And if you just specify in finance, it can detect fraudulent transactions within milliseconds, saving business millions. Whether it's improving customers or experience through personalized recommendation on platform like Netflix, or making a groundbreaking advancement in autonomous vehicle, or machine learning has become the backbone of modern technology. Kindly just observe, dear friend, what are all the exact steps we have. Yes, of course, we are having this exact path where the machine would just learn it and then make use of the prediction in the next stage. So once as it just making the learning in the best part, we can easily make the prediction or diagnosing or analysis very quickly and efficiently. Now, there are several several types of machine learning algorithm that falls into three major categories, that is supervised, unsupervised, and of course reinforcement learning. In supervised learning, the algorithm is provided with both input and of course output. And kindly just specify here, when we just specify both input data, of course it's just going to have the corresponding output labels. That is what the main thing. And it learns by analyzing the labeled training data and mapping it to the correct output. Think of it like teaching a student using something as a flashcard. The algorithm is shown the input and expected output until it learns the relationship. And this approach is commonly used in applications like spam detection in emails or predicting house price based on features like what is the size and about the location. And here, dear friends, common algorithms include here as like when coming to regression, yeah, it is linear regression. And yeah, you can just specify yes, a logistic regression for classification. And you can just specify support vector machines. So here it is specified Navis Bay tree, that is decision tree, KNN is there. And yeah, here under decision tree, under tree structure, you can just go for decision tree, or ensembled under you can just specify random forest. So many things are there. Yeah, of course, even you can just specify the neural network comes under here. Yes. Unsupervised learning is different. Here the data is not labeled. Yes, it is an unlabeled format. And the algorithm is tasked within finding structure in the data on its own. So this is usual when you are trying in discovering underlying patterns without explicit guidance. So for an instance, so when you just make a clustering customer based on some purchase habits or segmenting markets fall under this unsupervised algorithm. And here algorithms like k-means clustering, hierarchical clustering are very widely things is there, and even you can just specify something association analysis, and yeah, hidden Markov model, HMM model just comes under this one. Yeah, dear friends, when coming towards this reinforcement, yeah, it is a type of machine learning where the model learns through interaction with its environment. It learns by trial and error, receiving feedback in the form of rewards or penalties. This type of learning is used in autonomous systems like self-driving cars or robotics, as well as in game AI, where the model learns optimal strategies over time by interacting with its surroundings. And dear friends, yes, in this series, we are just going to mainly concentrate about the supervised and unsupervised algorithm. Later on next session or next series, we would just concentrate on reinforcement. Now, let me just see what is the exact traditional, we are just speaking about traditional. What is there here, machine learning versus traditional programming? Dear friends, traditional algorithms exactly follows a static set of rules defined by this program. If for an example, if we just say if A is happen, okay, then go and do this B or follow the B. So this rule basic logic works for straightforward problems like calculating taxes or sorting a list of names alphabetically. However, for more complex or dynamic problems like recognizing face or understanding the speech or translating languages, rule-based algorithm falls short. Okay, so because these tasks involve so many variables and subtitle variations, that it would be impossible to write rules for all of them. Okay, so this is where machine learning comes in. And here, instead, in this machine learning, instead of explicitly defining the rules, you give the system data and let it learn the rules on its own. For instance, if we just make it, of course, here we are just going to make the learning part, and once after learning, we are just going to make the prediction. So by using the test data, and here under learning, the training data would just go ahead. And for instance, in the case of an image recognition, see, a machine learning algorithm does not need to be told explicitly what a cat looks like. Instead, by processing thousands of images labeled as like whether it is a cat or not a cat, the algorithm can learn to identify cats on its own by making or recognizing the patterns in the pixel data. The more data it sees, the better it becomes as this task. And in contrast, of course, this traditional methods, okay, so this machine learning, this exact adapts and improve over time as it is exposed to more data and making it incredible powerful for task that requires flexibility and scalability. That is what the main thing where we just depend about this machine learning. Now let I just specify how this works. Dear friends, this machine learning would just follows a structured process to learn from the data and to make the decision to that of that task. So here, the first step, it is all about the data, and what is the main part here? It is, yes, when you just make on towards which project or any issues, what is the exact objective of the project. Once you understand about the objective of the project, you can just go towards the data. And it is very much important towards this data collection, which involves gathering the data the algorithm will learn from. So this could be anything from sensor data, or images, or customer transactions data, depending on the application. So once if you understand this objective exactly and correctly, there you can just collect the data accordingly towards the requirement. And next it comes about the data preparation. As dear friends, cleaning the data to remove any errors or dealing with missing data or missing values, and transforming the data into a format that the algorithm can understand. This exact step is critical because poor quality data can lead to poor model performance, no matter how advanced the algorithm is. Okay, once the data is prepared, we move to selecting, that is the model selection. This involves choosing the appropriate machine learning algorithm based on the nature of problem. For an example, if you are trying to predict a continuous value like house prices, you might choose a regression algorithm. For image recognition, a neural network might be more appropriate. Okay, next it is all about training phases. Yes, dear friends, the model in this training phases, the model is fed data and adjust its parameter to minimize error. The model tries to learn the relationship between the input data and the output labels, gradually improves its prediction. So this is an iterative process with the model adjusting itself based on the feedback. And once the model is trained, here we are going to make an evaluation. Here the model's performance is tested on a new set of data it has not seen before. So where you can just specify, you can just check its accuracy and generalization ability. And if necessary, we conduct hyperparameter tuning to adjust the model setting for optimal performance. Finally, in the deployment phase. Yes, dear friends, in the deployment phase, the trained model is put to use in the real world, making prediction or decision based on the new upcoming or incoming data. Dear friends, once on making the exact process or how it works, when you just know how it works, now it is very much challenging choosing the right machine learning algorithm. But there are few guiding principles, dear friends. Of course, the first one, when you just specify exactly, it is all about the data set. The data set size. Some algorithms like neural network performs well with large data sets, while simpler algorithm like a decision tree can work with smaller data sets. And kindly just let me just know, yes, accuracy, it is very much important. For high stake tasks such as medical diagnostic, a highly accurate model like a deep learning algorithm may be necessary. But if interpretability is more important, you might opt for simpler model like logistic regression. And kindly just observe, dear friends, the computation power, that is more complex models such as deep learning require significant computational resource. If you are limited in this regard, algorithms like decision tree or support vector machines may be a better fit. And of course, you are very much known towards the time, that is speed. If you need a real-time solution such as an autonomous driving or fraud detection, yeah, you will want a fast algorithm like a random forest or logistic regression that can make decision quickly. Dear friends, each and every algorithm, of course, when we just discuss on one by one the algorithm, yes, each algorithm has its strength and weakness. So understanding the problem domain and available sources is critical to making the right choice. So yes, when we just go through all the algorithms, kindly just be conscious which it can be done and which is not. So do's and don'ts to be noted consciously, and you have to follow which is worth towards this objective of the project or objective of towards that issues or problem statement, whatever you just specify. Okay, yes. Now there are so many use cases are there. Yes, of course, machine learning is already being used in various industries with some incredible use cases leading to major breakthrough. Yes, of course, here or there. So energy, feedstock, utilities is there. Financial service, travel and hospitality, manufacturing, retail, healthcare and life science. Of course, in healthcare, machine learning algorithms can predict diseases, optimize treatments, and even assist in complex surgeries using computer vision. So the ability to process medical image quickly and with high accuracy has revolutionized the diagnosing tool. So potentially saving lives, okay. And coming towards in financial, machine learning is behind fraud detection system or something as like spotting unusual patterns in transaction data that human analysts might miss. And algorithms also drive algorithmic trading. Whether machine executes trades at lightning speed based on the market trends. And coming towards this retail, yeah, personalized marketing and recommendations engine that drives sales by predicting what customers want. And whether it's your Netflix recommendation or targeted ads on social media or machine learning is at work, exactly. And when coming towards the transportation, yes, dear friends, machine learning is powering self-driving cars and optimizing logistics by predicting traffic patterns and optimizing routes, saving time and fuel. These are just a few examples, but the scope of machine learning application is virtually limitless. And when coming towards challenges, dear friends, while machine learning holds great promises, it's not without its challenges. As I was specifying one thing about that quality, yes, the performance of machine learning models is heavily reliant on the quality of the data. That incomplete, inconsistent or biased data that can lead to inaccurate prediction or potentially causing harm. especially in sensitive industries like healthcare. And of course, you can just specify yes, bias and fairness. Machine learning models can inherit biases present in the training data. If the data used to train a model is biased, say it overrepresents one group while underrepresenting another. So the model's prediction can reflect and even amplify these biases. Next, it comes all about the overfitting. Of course, see, rather than just specifying all these advantages and disadvantages, yes, of course, we have already come across all these one. I have specified, yes, related towards the bias, related towards the variance and overfitting. Yes, dear friends, when coming towards this overfitting, sometimes a machine learning model performs exceptionally well on training data, but poorly on new that is unseen testing data. So this phenomena, of course, called overfitting, that we have already discussed. And when coming towards the resource intensity, that is very much important. Intensity. So training advanced models, especially deep learning algorithms, require substantial computational power and time. Companies may need to invest in specialized hardware such as GPUs and cloud resources, which can be expensive. And rather specifying here, of course, ethical concern, as machine learning is integrated into more aspects of society, ethical concerns arise. Particularly around privacy and potential misuse of predictive models. Here, it's crucial to consider these aspects when deploying machine learning solution. Addressing these challenges requires careful design. Dear friends, continuous monitoring and use of ethical framework, that is to ensure responsible and fair outcomes. So yes, challenges, as I have already specified, challenges are there. So many things are there. And of course, machine learning, as it holds a great promise, it is not without such challenges. Okay, yes, last but not least, yes, dear friends, machine learning is a transforming industry across the board, and its applications are expanding rapidly. In education, yes, adaptive learning platforms are tailoring education content to meet individual student needs, helping them learn at their own pace. Yes, of course, cyber security. So, dear friends, actually here, of course, I have already specified something, but other than the thing which I have missed here, yeah, specifying as like education, cyber security, yes, machine learning algorithm detect anomalies in network traffic and identify potential threats, preventing cyber attacks before they can cause significant damage. And of course, which I have just didn't specify, agriculture. In agriculture, machine learning is being used to predict crop yield, optimize irrigation, and detect plant disease early, helping farmers increase productivity and reduce waste. And yes, when you just go with the entertainment, yes, different streaming services like Spotify and Netflix that uses machine learning to recommend content and offering personalized experience based on the user's past behavior. And in smart city, machine learning helps manage traffic flow, energy usage and public safety, making urban environment more efficient and livable. Rather than specifying here, yes, of course, the space exploration, machine learning being used to process a massive amount of data collected by satellites and recover, helping scientists make sense of distant planets and galaxies. Dear friends, here, whichever I have just specified here and also I have listed here, these are just example shows how machine learning is not just a tool for tech companies. It reshaping industries and paving the way for new innovations across all fields. Dear friends, as we journey deeper into the age of artificial intelligence, machine learning stands as one of the humanity's greatest tool of innovation. So from revolutionizing industry to solving some of the world's most complex problems, it's clear that a potential of most complex problem, that is machine learning, is only limited by our imagination. But as we embrace this technology, we must also understand its power, and with that power comes responsibility. It's not just about what machine can learn from us, but what we as a society can learn from this technology to build a more intelligent or equitable and sustainable future. As the data continues to grow, so too will the impact of machine learning, driving us towards a world where possibilities are endless. So yes, dear friends, from this day onwards, we are just going to discuss every algorithm one by one with an end-to-end project. And hope, I think so, you are found this video helpful. So if you found this video helpful, don't forget to hit the like button and kindly just subscribe the channel and turn on the notification so you don't miss any of my upcoming content. And dear friends, if you have any queries or anything, drop a comment below. So if you have any questions or suggestions also, kindly just share your thoughts. And yes, as I always specify, keep learning and stay curious. See you in next video, dear friends. Happy learning.